We'll be talking about geometric sequence. We have the formula for a geometric sequence. We have a sub n is equal to a sub 1 multiplied by r raised to n minus 1. Your a sub n here is your last term, or it is the nth term, which is being prescribed in a geometric sequence. Your a sub 1 is your first term in the given geometric sequence. Your r here is common ratio. Your n is the position of the sequence or the term that is being looked for. Okay, so let's have an example. Let's say we have 3, 6, 12, 24, 48, and so on and so forth. But you are asked to look for, let's say, the 18th term. You're going to find out, let's say, the 18th term of this. We're looking for a sub 18. We're going to look for the 18th term of this given geometric sequence. To use this formula, of course, you have to identify first whether the sequence is following a definite pattern. So again, a geometric sequence is defined to be, it is a sequence wherein the next term or the following terms are being determined by multiplying the previous term using a constant number, and that constant number is known to be your common ratio, which is denoted by r. Okay, let's go back with our first example. So if we are going to look for our a sub 18 in this given sequence, we are just going to follow your formula. So we have a sub 18 is equal to, what is our first term? Our first term is, we have 3. Then we have r raised to n minus 1. But here, we still do not know our common ratio. And to determine our common ratio, we have r is equal to the ratio or the quotient of a sub 2 and a sub 1. Our a sub 2 in our given problem here is equal to 6. 6, and our a sub 1 is equal to 3. Now, we will divide. What is the quotient of 6 and 3? Of course, it is equal to 2. So now, we are ready to substitute the value of r, or our common ratio, in our formula. So now, we have a sub 18 is equal to 3, your first term, multiplied by 2. This is your common ratio. Then our n is definitely equal to 18 minus 1. Your minus 1 as used in your exponent here, that's definite. You cannot change that. So now let us simplify further. So we have a sub 18 is equal to 3. Do not multiply your 3 and your 2. Remember that we have to find out the result first of this using your PEMDAS or your MDAS. So we have to exponentiate so that we can simply determine the value of 2 raised to the difference between 18 and 1. So now we have 2 raised to 17. We are going to simplify the value of 2 raised to 17. Now we have a sub 18 is equal to 3 times 2 raised to 17 would mean to say you are going to multiply 2 by itself 17 times. So this means to say 2 times 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 2, and so on and so forth until multiplying your 2 until this until it reaches its 17 times. So this is multiplying 2 by itself 17 times. So 2 raised to the power of 17 is equal to 131,072. This is now the result. If you will simplify 2 raised to the power of 17, it is equal to 131,072. Then now the value of our a sub 18 would be, you multiply 3 and 131,072 by 3. So the answer is equal to 393,216. So this is now the value of our 18th term of the given geometric sequence. Another example. Let's say we have 9, negative 27, then we have 81, and so on and so forth. We are going to look for the value of, let's say, a sub 12. We are going to find out our 12th term in the given geometric sequence. Of course, the first thing to do is you look for R. So a sub 2 divided by a sub 1. This is our a sub 1, a sub 2, a sub 3. So you are going to use your a sub 2, which is equivalent to negative 27. Then our a sub 1 is equal to 9. Then get the quotient of negative 27 and 9. The result is equal to negative 3. Okay, it's negative 3 because we are applying or following the concept. If we have two unlike signs, then the sign of the quotient would always be negative. So now, using your formula, a sub 18, a sub 12, is equal to, we have our a sub 1. What is our a sub 1? It is equal to 9. Okay. Then, times, our common ratio is raised to the power of negative 3. So, negative 3, then we have 12, right? That is our n, 12 minus 1. So, we have a sub 12 or our 12th term, 9 times. We have negative 3 and 12 minus 1 as exponent of your base negative 3. We have here 11. So a sub 12 is equal to 9 multiplied by, we are going to simplify, negative 3 raised to the power of 11. So now we have negative 3 raised to the power of 11. That would be equal to negative 177,147. So always remember that you cannot multiply your constant negative 3 or the coefficients negative 3 and 9 right away. You need to simplify first the term with exponent. So let us multiply 9 and negative 177,147. That would be equal to, we have negative 1,594,323. So this is now the 12th term of this geometric sequence. Always remember that in getting the nth term of a geometric sequence is you use the formula a sub n equals a sub 1 r raised to n minus 1, wherein you need to determine first whether the given sequence follows a definite pattern or if it has a common ratio between the different terms, or among the terms they should have the common ratio. So that is the first thing, you need to identify your common ratio, and our common ratio would be the quotient of your a sub 2 and your a sub 1. And again, a geometric sequence is a kind of sequence wherein the succeeding or the following terms are being determined or distinguished by multiplying the preceding term or the previous term by a common constant. And the constant is known to be your common ratio. Okay, so that's it. Thank you.